Good morning, gardeners, and welcome to Friday, June 30th. My name is Catherine, and I created a show called Good Morning Gardeners, even though I can't grow green things because I am referring to gardening metaphorically. We're planting the seeds for a better day. We're starting our morning by getting in the right mindset to cultivate a better life for ourselves, better communities, and a better world. If you like this video, please give it a thumbs up and subscribe if you'd like to add Good Morning Gardeners to your morning routine. I do my best to wake you up with positive and mentally stimulating ideas, but sometimes I miss things. If you have something to add to the ideas I discussed today, please chime in the comments section below. Today is International Asteroid Day. This day aims to raise public awareness about the asteroid impact hazard and to inform the public about the crisis communication actions to be taken at the global level in case of a credible near-Earth object threat. Near-Earth objects, or NEOs for short, represent potentially catastrophic threats to our planet. An NEO is an asteroid or comet which passes close to the Earth's orbit. According to NASA's Center for NEO Studies, over 16,000 near-Earth asteroids have been discovered. The Tunguska asteroid event in Siberia on June 30, 1908 was the Earth's largest asteroid impact in recorded history. The United Nations Office for Outer Space Affairs has worked on NEOs for many years, recognizing an NEO impact hazard as a global issue demanding an international response. Addressing such a hazard, including the identification of those objects that pose a threat of impact and planning a corresponding mitigation campaign, requires cooperative action in the interest of public safety on the part of the global community. Building on recommendations for an international response to a near-Earth object impact threat, the International Asteroid Warning Network and the Space Mission Planning Advisory Group were established in 2014. The International Asteroid Warning Network uses well-defined communication plans and protocols to assist governments in the analysis of possible consequences of an asteroid impact and to support the planning of mitigation responses. So I am not sure whether this was planned or not, or, whether it's a coincidence or a synchronicity or what, but the thing that I have been thinking about this morning is also space related. A few days ago, I heard that the astrophysicists were going to announce something big on June 28th, and this morning I woke up to news that science's current understanding of physics is about to change once again. Now, for this to make sense, you have to bear in mind that I record these episodes 24 hours in advance, and I'm 6 hours ahead of the American East Coast because I live in Germany. Now, because all these physicists are in the United States and Canada, they probably made these announcements that I saw this morning, last night, which is why I didn't see them until this morning. So, these physicists are part of an organization called NANOgrav, and last night, or 2 days ago for you, they released a series of papers describing their findings from 15 years of collecting data while observing phenomena in outer space. To make the timeline even more confusing, they are going to be making a full announcement, including an analysis of the significance of this data later today on a live YouTube video, which is going to be actually this evening for me, but yesterday afternoon for you. If all this timeline stuff is confusing for you, don't worry, because early analysis that I've seen has indicated that the NANOgrav data proves that time isn't as stable as we think it is. Now, because I am an artist, not a scientist, I am going to explain what I am talking about by reading an article recently published by Caltech, which is titled, "Scientists Find Evidence for Slow-Rolling Sea of Gravitational Waves." Scientists are reporting the first evidence that our Earth and the universe around us are awash in a background of space-time undulations called gravitational waves. The waves oscillate very slowly over years and even decades, and are thought to originate primarily from pairs of supermassive black holes leisurely spiraling together before they merge. The findings, reported in a series of papers in the Astrophysical Journal Letters, come from 15 years' worth of observations made by the North American Nanohertz Observatory for Gravitational Waves, or NANOgrav for short. A National Science Foundation-funded physics frontier center of more than 190 scientists from the United States and Canada, NANOgrav used data from radio telescopes to monitor 68 dead stars called pulsars in the sky. The pulsars acted like a network of buoys bobbing on a slow rolling sea of gravitational waves. The effect of the gravitational waves on pulsars is extremely weak and hard to detect, but we built confidence in the findings over time as we collected more data, says Katerina Chatsianu, a NANOgrav team member and an assistant professor of physics at Caltech. In the future, we will continue to make more observations and will compare our results with those from international partners, which will allow us to learn more from the data. We have a new way of probing what happens as monstrous black holes at the cores of galaxies begin a slow but inexorable death spiral, says Joseph Lazio, a NANOgrav team member. We think that this process is standard for many galaxies, and we've seen many examples at various steps, but we're finally starting to glimpse one of the key final steps. Gravitational waves were first proposed by Albert Einstein in 1916, but were not directly detected until about 100 years ago when the Laser Interferometer Gravitational Wave Observatory, or LIGO for short, picked up the waves from a pair of distant colliding black holes. LIGO detects gravitational waves that are much higher in frequency than those registered by NANOgrav. Higher frequency gravitational waves come from smaller pairs of black holes zipping around each other rapidly in the final seconds before they collide, while the lower frequency waves are thought to be generated by huge black holes at the hearts of galaxies, up to billions of times the mass of our Sun, that lumber around each other slowly and have millions of years to go before they merge. In the new studies, NANOgrav is thought to have picked up a collective hum of gravitational waves from many pairs of merging supermassive black holes throughout the universe. People compare this signal to more of a background murmur as opposed to the shouts that LIGO picks up, explains Chatsianu, who is also a member of the LIGO team. It's as if you were at a cocktail party and you can't pick out any one individual voice. We just hear the background noise, says Patrick Myers, another NANOgrav team member. NANOgrav's network of pulsars is also known as a pulsar timing array. The pulsars, which formed from the explosions of massive stars, send out beacons of light that rapidly spin around at very precise intervals. These are like lighthouse beacons that sweep by at a regular rate. You can predict the timing to a level of tens of nanoseconds. They have the same level of precision of atomic clocks in some cases, says Myers. When gravitational waves travel across the cosmos, they stretch and squeeze the fabric of space-time very slightly. This stretching and squeezing can cause the distance between Earth and a given pulsar to minutely change, which results in delays or advances to the timing of the pulsar's flashes of light. To search for the background hum of gravitational waves, the science team developed software programs to compare the timing of pairs of pulsars to their network. Gravitational waves will shift this timing to different degrees depending on how close the pulsars are. Imagine lots of ripples on an ocean from pairs of supermassive black holes scattered throughout, says Lazio. Now, we are sitting here on Earth, which acts like a buoy along with the pulsars, and we try to measure how the ripples are changing and causing the other buoys to move toward and away from us. In the future, the scientists hope to answer mysteries about the nature of merging supermassive black holes, such as how common they are, what brings them together, and what other factors contribute to their coalescence. This was such a beautiful, unlikely experiment, assembling a galactic-sized gravitational wave detector animated by the pulse of dead stars across our galaxy and bringing together a multidisciplinary team of radio astronomers, neutron star and black hole experts, and gravitational wave scientists. So, as I said, I am not a scientist by trade, so I won't attempt to explain the significance of this announcement this morning. If you would like to check out the 15-year data release or watch the recording of the live that I mentioned, I've put a link in the description of this video. But for now, I am going to give you a bit more science talk before moving on, and I will be reading from A Brief History of Time by Stephen Hawking about time and space. The theory of relativity gets rid of absolute time. Consider a pair of twins. Suppose that one twin goes to live on the top of a mountain while the other stays at sea level. The first twin would age faster than the second. Thus, if they met again, one would be older than the other. In this case, the difference in ages would be very small, but it would be much larger if one of the twins went for a long trip in a spaceship at nearly the speed of light. When he returned, he would be much younger than the one who stayed on Earth. This is known as the twins paradox, but it is a paradox only if one has the idea of absolute time at the back of one's mind. In the theory of relativity, there is no unique absolute time, but instead, each individual has his own personal measure of time that depends on where he is and how he is moving. Before 1915, space and time were thought of as a fixed arena in which events took place, but which was not affected by what happened in it. This was true even of the special theory of relativity. Bodies moved, forces attracted and repelled, but time and space simply continued, unaffected. It was natural to think that space and time went on forever. The situation, however, is quite different in the general theory of relativity. Space and time are now dynamic quantities. When a body moves or a force acts, it affects the curvature of space and time, and in turn, the structure of space-time affects the way in which bodies move and forces act. Space and time not only affect, but also are affected by everything that happens in the universe. Just as one cannot talk about events in the universe without the notions of space and time, so in general relativity it became meaningless to talk about space and time outside the limits of the universe. In the following decades, this new understanding of space and time was to revolutionize our view of the universe. The old idea of the essentially unchanging universe that could have existed and could continue to exist forever was replaced by the notion of a dynamic, expanding universe that seemed to have begun at a finite time and that might end at a finite time in the future. Now, I have said multiple times in this episode that I am not a scientist, so you might be wondering why I am so interested in this topic. And the answer is that I am interested in discovering secrets. The implication that astrophysicists had discovered a secret of the universe was exciting to me. I think that most of us can get excited about learning new secrets and discovering new things if we really think that that is possible. But unfortunately, most people seem to believe, at least on some level, that there are no secrets left to discover. In 0 to 1, Peter Thiel talks about discovering secrets as a way to discover the next great startup idea. But I believe that discovering secrets can be useful for anyone, even if you don't care about starting a startup and aren't interested in starting a business. New discoveries about life can offer you more freedom, more power, and inject joy and even magic into your life. Now, here's what Peter Thiel writes about secrets. Every one of today's most famous and familiar ideas was once unknown and unsuspected. The mathematical relationship between a triangle's sides, for example, was secret for millennia. Pythagoras had to think harder to discover it. Pythagoras had to think hard to discover it. If you wanted in on Pythagoras' new discovery, joining his strange vegetarian cult was the best way to learn about it. Now, his geometry has become a convention, a simple truth that we teach to grade schoolers. A conventional truth can be important. It's essential to learn elementary mathematics, for example, but it won't give you an edge. It's not a secret. Remember the question I proposed to you, called the contrarian question. What important truth do very few people agree with you on? If we already understand as much of the natural world as we ever will, if all of today's conventional ideas are already enlightened, and if everything has already been done, then there are no good answers. Contrarian thinking doesn't make any sense unless the world still has secrets to give up. Of course, there are many things we don't yet understand, but some of those things may be impossible to figure out, mysteries rather than secrets. For example, string theory describes the physics of the universe in terms of vibrating one-dimensional objects called strings. Is string theory true? You can't really design an experiment to test it. Very few people, if any, could ever understand all of its implications. But is that just because it's difficult? Or is it an impossible mystery? The difference matters. You can achieve difficult things, but you can't achieve the impossible. The actual truth is that There are many more secrets left to find, but they will yield only to relentless searchers. There is more to do in science, medicine, engineering, and in technology of all kinds. We are within reach, not just of marginal goals set at the competitive edge of today's conventional disciplines, but of ambitions so great that even the boldest minds of the scientific revolution hesitated to announce them directly. We could cure cancer, dementia, and all the diseases of age and metabolic decay. We can find new ways to generate energy that free the world from conflict over fossil fuels. We can invent faster ways to travel from place to place over the surface of the planet. We can even learn how to escape it entirely and settle new frontiers. But we will never learn any of these secrets unless we demand to know them and force ourselves to look. Now, in that chapter, Peter Thiel also writes, there are two kinds of secrets. Secrets of nature and secrets about people. Natural secrets exist all around us. To find them, one must study some undiscovered aspect of the physical world. Secrets about people are different. They are things that people don't know about themselves or things that they hide because they don't want others to know. I would take it a step further. I believe that humans are a part of nature, and that by discovering things about ourselves, we discover things about the world. That means that each of us holds the secrets of the universe within us. And if it's inside you, you definitely have the power to discover it. If you let it happen, the world will trick you into thinking that everything has already been discovered and that everything is already known. And your job is simply to follow someone else's lead without discovering any secrets of your own. And if you're not careful, the world will even push you into fulfilling a societal role that isn't authentic to who you truly are. So for our focus moment this morning, I want you to ask yourself, what secrets are there within you right now? What do people tend to assume about you that isn't true? What are you in the habit of believing about yourself that also might not be true? You are the chief explorer in the expedition to find yourself, so only you can decide what is really true about you. When you find them, I encourage you to speak your secrets out loud, at a minimum sharing them with someone you trust. Because something that we already do know about humans is that we are social creatures, and we can get to know ourselves better by sharing ourselves. So sharing your truth is a potential path toward discovering the secrets of the universe. I hope you found this helpful, and I hope you have a wonderful day and a wonderful weekend. I will speak with you again on Monday.